Today we're going to learn another way to solve a quadratic equation. Yesterday we learned how to solve a quadratic equation by getting it in standard form, which meant set it equal to 0, factor in t-bar to find our values of x or our roots. Well, today's method, which is also called the square root property, is called completing of the square. What it does, it manipulates the equation until one side is a perfect square. Now you're going to say, well, why do we need to know another method if we just learned how to factor in t-bar? Well, as you know, not all the equations are factored easily. Sometimes you have to use the dreaded trial and error, which we all know we don't like. So whenever you're actually solving a quadratic equation and it happens to be a trial and error, completing of the square works so much nicer for that. Also, completing of the square is asked on every single exam. They may ask you a question like, what would be the next step in solving this equation using completing of the square? Or they may say to you, solve the following equation using completing of the square. So really, you have no choice then. You have to use this method. If you notice, we have quite a few steps here. So I want you to take a minute, pause the video, copy all the steps, and then come back so we can use all those steps to work on number 1. Okay, so you have all the steps written down now. Let's take a look at how we can actually solve for our values of x or our roots in number 1 by using completing of the square. Well, it says in the first step that we have to set it equal to our c value instead of having it equal to 0 like we did yesterday. All right, our c value in this case is a negative 11. So in order to move that 11 to the other side, we're going to add 11 to both sides. So we now have x squared plus 10x equals 11. We have to make sure our a value is a 1. And in this case, it is a 1 because there's no integer in front of the x squaring, which is understood to be a 1. All right, now it says take the b value, which is our 10, divide it by 2 and square it. So off to the side, 10 divided by 2 squared is 25. Take that result and add it to both sides of my equation. So I'm going to add 25 to both sides of the equation. And now I have x squared plus 10x plus 25 equals 36. Now the next step may be a little complicated. It says to write the left side of the equation as a perfect square, which means if I factor it, I want to make sure both of my factors are exactly the same. So I'm going to go off to the side of my paper here, and I'm going to take x squared plus 10x plus 25 and actually factor it. I can't GCF, so I'm going to go to 2 binomials. I get an x and an x, factors of a positive 25, that'll give me 10, plus 5 and plus 5. It is considered to be a perfect square because x plus 5 times x plus 5, they're exactly the same. So another way of writing it is x plus 5, the whole thing squared. So now it's a perfect squared binomial. So what I'm going to do now is rewrite x squared plus 10x plus 25 as x plus 5, the whole thing squared. The next step says I need to square root both sides. The reason you're doing that is because of this guy right here, this squaring. You have to get rid of him, and the way to undo squaring is to square root. So I'm going to square root this side, but whatever you do to one side of an equation in algebra, you have to do to the other. All right, on the left, I will end up with x plus 5. On the right, let's go over to the side of our paper and talk about what we're going to end up with on the right side. The square root of 36, I'm sure right now everybody is saying 6, and you're correct. But because you drew the square root symbol, we're really not sure what answer they want. And you're going to say, well, what do you mean what answer, Mrs. Carr? There's only one answer, it's 6. Well, really there isn't. The square root of 36 is also a negative 6. Think about it. A negative 6 times a negative 6 is also a positive 36. So you really truly have two answers. Since they didn't draw the symbol by indicating which answer they want, we drew the symbol, we're going to have to make sure we give them both. So now x plus 5 is going to be set equal to plus or minus 6, which is positive or negative 6. Now this is where we're going to split it because we have it set equal to two answers. So we have x plus 5 equals a positive 6, and we have x plus 5 equals a negative 6. So now we have two equations to solve. On the left, if we subtract 5 on both sides, we get x is a positive 1. On the right, if we subtract 5 on both sides, we get x is a negative 11. So the answers to this equation are x equals 1 and x equals a negative 11. Another name for answers or values of x are called my roots. And then the very last step says that you need to make sure that you take your answers and put them back in the equation and check it. And just to save a little bit of time today, I'm going to tell you that they do check. But again, when you're working on something, you need to double check to make sure your answers check, because if they don't, you might have made a mistake, or you might have to reject one of them or both of them. All right, now that we've gone through one example nice and slowly, let's go through a couple more examples a little bit more quickly. Example number 2. X squared minus 4x minus 2 equals 0. We're going to solve it by doing completing of the square. Okay, we need to make sure it's set equal to our c value, so we're going to add 2 to both sides. Now we have x squared minus 4x equals 2. Is our a value 1? Yes, it is. So we're golden there. We're going to take our b value, which is a negative 4. We're going to go off to the side. We're going to actually divide it by 2 and then square it. And we'll end up with a positive 4. We're going to take that answer and add it to both sides of our equation. Now we have x squared minus 4x plus 4 equals 6. Okay. Now we want to factor that trinomial so it's a perfect squared binomial. So go off to the side of your paper, take a couple minutes, factor it, pause the video, and then come back and see if you achieved what I did. All right, did you end up with x minus 2 times x minus 2? If you did a great job. So now we're going to write x minus 2 squared equals 6. We're going to undo the squaring by square rooting, but whatever we do to one side, we have to do to the other. So now we have x minus 2 equals, can you square root 6 evenly? No, you can't. You can't even try to simplify because there's no perfect square root that'll go into 6. So the best way to write this answer would be a plus or minus radical 6. So now we're going to split it. We're going to have x minus 2 equals radical 6, and x minus 2 equals a negative radical 6. So we're going to solve each one at a time. We're going to add 2 to both sides to the one on the left, and we're going to end up with x equals, whenever you're adding to a radical, you always want to put it in front of the radical. So it'll be 2 plus radical 6, because remember the radical 6 is positive. On the right, we're going to add 2 to both sides, and we're going to end up with x equals 2 minus radical 6, because remember, in that case, the radical was a negative. We can't go any further because we can't simplify the radical 6, so those are our values of x. Another way you may see this written is x equals 2 plus or minus radical 6. It's just showing you an easier way to write it and that it can't be simplified anymore. All right, let's take a look at number 3 together. First things first, we're going to need to move our c value to the other side. So what we're going to do in this case is add 24 to both sides. And this time I'm not going to show it, I'm just going to do it. So I'm going to have 2x squared minus 8x equals 24. Okay, now is my a value 1? It's not this time. This time it's a 2. I have to get it to be a 1. Now it's a multiplying 2, so the only way I can actually change that multiplying 2 to a 1 would be to divide it by 2. So what I'm going to do is I'm going to divide it by 2, but if I divide that term by 2, I have to divide every term by 2, even the term on the other side of the equal sign. So now I'm going to have x squared minus 4x equals 12. So now I have a brand new equation to work with. My c value is to the other side, and my a value is now a 1. So now I'm ready to move on. I need to take my b value, so I have a new b value. It's a -4. I go off to the side. I divide it by 2 and square it. And I get a +4. I'm going to add that b value to both sides. And I have x squared minus 4x plus 4 equals 16. Now if you notice, it's the exact same trinomial as we had just above. So this one's easy to factor because I know exactly what it is already. So go back to my problem, and I know it's going to be an x minus 2, the whole thing squared. I'm going to get rid of the squaring by square root both sides, and I will have x minus 2 equals plus or minus 4. I'm going to split it and get x minus 2 equals 4, and x minus 2 equals -4. On the left, I'm going to add 2 to both sides and get x is 6. On the right, I'm going to add 2 to both sides and get x is a -2. I'm going to check my answers to see if they work, and in this case, I know they work. So I'm going to say that my values of x, or my roots, are 6 and -2. Now, what do you mean, Mrs. Carr? You know they both work. Well, let's talk about that a little bit. I would take the 6 and I'd plug it back into the original equation. So 6 squared is 36. 36 times 2 is 72. 8 times 6 is 48. So if I subtracted 72 minus 48, I get 24. And then 24 minus 24 is 0. So it works. And then you'd have to do the same thing for the -2. Okay. Let's take a look at another example. And this is our last example. I'm going to start it with you, and then I'm going to stop, because I want you to be able to finish it on your own. But there's a couple of things I want to go over with you before we start this example. When we ended up with, on the right side of our equation, let's say the square root of 6, we knew that we can't take the square root of 6 evenly, and that we couldn't even simplify it, so we left it as plus or minus radical 6, which is okay. And when we ended up with square rooting a perfect squared number, let's say, for example, 25, we would end up with plus or minus 5, because we could simplify that. Well, if we end up with, let's just say, radical 8, square root of 8, we can simplify radical 8 because one of the factors of 8 is a perfect square root. It's 4 times 2. 4 being the perfect square root. Square root of 4 is 2, and the 2 stays under the radical because it's not a perfect square root. So we would end up with plus or minus 2 radical 2. So if you can simplify that radical, you really need to do so. All right, let's go back to example number 4. Just going to again start you off, and I want you to finish this one for homework and bring it into class tomorrow, and then we will review it together. First things first, we have to move our c value to the other side. So we're going to add 42 to both sides, and we're going to end up with 3x squared minus 12x equals 42. Now, our a value is not a 1. It's a 3. So we're going to need to divide that term by a 3, but in doing so, we have to divide every term by a 3. Okay, that's where I'm going to leave you today. I want you to take a couple minutes, finish it, bring it to class tomorrow, and then we'll check to see how well you did. I hope you have a great night.